Our universe is a vast and wondrous place. Imagine a giant tapestry woven with billions upon billions of stars. These stars cluster together to form galaxies, swirling islands of light scattered across the cosmos. Our own Milky Way galaxy is just one of these sparkling jewels. This cosmic tapestry, however, is not static. It's constantly shifting, evolving, and perhaps even hurtling towards its ultimate fate. But how will it all end? Will the universe go out with a bang or a whimper? Cosmologists, those who study the universe on the grandest scales, have offered two compelling yet dramatically different scenarios: the Big Rip and the Heat Death. Both involve the ultimate fate of everything we see and everything we don't. Both leave us pondering our place in the universe and the legacy of existence itself. To understand the possible endings of the universe, we first need to grasp a fundamental concept. The universe is expanding. Imagine baking a loaf of raisin bread. As the dough rises, the raisins embedded within it move further apart. Similarly, galaxies act as raisins in the dough of space-time, growing more distant as the universe itself expands. This expansion isn't just the galaxies moving through space, it's space itself stretching, carrying the galaxies along for the ride. This expansion was first observed in the 1920s by astronomer Edwin Hubble. He noticed that distant galaxies were moving away from us, and the further away they were, the faster they seemed to be receding. It was as if the universe had experienced a massive explosion in the distant past, propelling everything outward. We call this event the Big Bang, but the Big Bang wasn't like an explosion in the traditional sense. It wasn't an event that happened space, it was the event that space and time as we know it. And this expansion, it turns out, isn't slowing down, it's accelerating. The discovery of the universe's accelerating expansion was a shock. It implied the existence of a mysterious force dubbed dark energy that counteracts gravity and pushes everything apart at an ever-increasing rate. This discovery is what led to the theory of the Big Rip. Imagine a force so powerful that it could eventually overcome all other forces in the universe, even the forces holding matter itself together. In the Big Rip scenario, dark energy grows stronger over time. The expansion of the universe accelerates so rapidly that galaxies are torn asunder. Stars are ripped apart, and even atoms themselves are shredded into their constituent particles. It would be the ultimate cosmic unraveling, a dramatic end to the universe as we know it. The Big Rip, if it comes to pass, would be a far cry from the quiet, cold end predicted by the theory of heat death. Dark energy remains one of the most profound mysteries in modern cosmology. We can't see it, touch it, or directly detect it. We only know it's there because of its effects on the expansion of the universe. Think of it like the wind. You can't see the wind itself, but you can see the leaves rustling in the trees or feel it against your skin. Some scientists believe dark energy is a property of space itself. As the universe expands, more space is created, and with it more dark energy. This positive feedback loop could explain the accelerating expansion of the universe and ultimately lead to the Big Rip. If dark energy continues to increase in strength, the Big Rip could occur in as little as 22 billion years. That may seem like an eternity, but it's a blink of an eye on cosmic timescales. Section 5, Heat Death, the universe's slow fade. In stark contrast to the violent end predicted by the Big Rip, heat death offers a far more gradual and, dare I say, peaceful end to the universe. It's the ultimate expression of entropy, the tendency for systems to move from order to disorder. Imagine a cup of hot coffee left on a table. Over time, the coffee cools down as its heat energy dissipates into the surrounding air. Eventually, the coffee, the air in the room, and everything else reaches a state of thermal equilibrium, the same temperature throughout. This is, in essence, the ultimate fate of the universe according to the heat-death scenario. Stars, the cosmic furnaces that light up the universe, will eventually exhaust their nuclear fuel and burn out, leaving behind only cold, dark remnants. Galaxies, no longer held together by the gravitational pull of stars, will drift further and further apart. The universe will become a vast, empty expanse populated by fading light and cooling embers. Section 6. Entropy, the arrow of time. The concept of entropy is central to understanding heat death. It's often described as the arrow of time because it dictates the direction in which events unfold. Think about a sandcastle on the beach. It takes energy and effort to build a sandcastle, creating order from disorder, but leave it alone and the wind and waves will eventually reduce it back to a pile of sand. This is entropy in action. The second law of thermodynamics states that entropy always increases over time in a closed system. The universe, as far as we know, is a closed system. There's no outside to pump in new energy or order. Therefore, the universe is destined to become increasingly disordered, eventually reaching a state of maximum entropy, heat death. This final state, however, is still billions, if not trillions of years away. It's a fate so far in the future that it's almost incomprehensible on human timescales. Section 7. A universe of possibilities. The Big Rip and heat death represent two very different yet equally awe-inspiring endings for our universe. Which one is more likely? The truth is we don't know for sure. Our understanding of dark energy is still in its infancy, and new discoveries could completely change our understanding of the universe's fate. Perhaps there are other possibilities we haven't even considered. Some theories propose a cyclical universe where expansion is followed by contraction, leading to another Big Bang. Others suggest the existence of a multiverse, an infinite collection of universes, each with its own unique properties and ultimate fate. The study of cosmology is a journey into the unknown. It's a reminder of just how much we still don't understand about the universe and our place within it. But that's the beauty of it all, isn't it? The mystery, the wonder, the endless possibilities. Section 8. The enduring mystery. As we gaze up at the night sky, filled with countless stars and galaxies, we are confronted with the profound questions of existence. Where did it all come from? How will it all end? These are questions that have captivated humankind for centuries, and they continue to drive our exploration of the cosmos. Whether the universe ends in a big rip, a heat death, or some other unimaginable event, one thing is certain: the universe is a dynamic, ever-evolving place. It's a cosmic dance of creation and destruction, of order and chaos. And we are fortunate to be witnesses to this grand cosmic spectacle, however fleeting our time may be. So, how do you think it will all end? The answer might surprise you. The journey of discovery begins with a single question. Keep looking up, keep asking questions, and never stop exploring the wonders of the universe.